The last topic we're going to cover on completable futures before we move on to our next topic is enhancements to the Java completable futures framework that have come in later versions of Java. So there was the original version that came in Java 9, or in Java 8 rather, and then later versions of Java added more stuff. So here are some of the things that were added in Java 9 to Java 8, and then there's a couple of other things that came later which are insignificant, but these are the ones in Java 9 that are important. So the first one was that they added this new method called default executor, which returns the default executor used for methods that don't specify an executor, which usually will default to the common fork join pool. But if you change it, then you can have default executor return whatever you change it to. The next thing they added was this very funky method called complete async. Remember, we had this method called completed future, and we had this method called supply async. Well, now we have a method called complete async, which completes the completable future asynchronously using a value given by the supplier. So it's very much like the complete method, but now it's the async version of that. You'll see I came up with a convoluted use case for it, but it's not the most useful thing. The next couple methods were actually pretty useful. There's something called or timeout and something called complete on timeout. The or timeout method takes a timeout and a timeout unit, and what it'll do is it will end up throwing the timeout exception unless the completable future completes before the specified timeout. So you give it a timeout, and if your asynchronous computation finishes before that timeout, all is well. If it's longer than that timeout, then the timeout exception will be thrown. So that's a way of doing timed behaviors without having to have a timed call on join, for example. And then the final version is complete on timeout, which will complete the completable future with a given value if it's not otherwise completed before the given timeout. So this throws an exception when things time out, whereas complete on timeout gives a default value if things time out. So you can see those are both useful features. They both have their place. One throws an exception, one gives a default value. So let's take a look and see how you can actually use these methods to good effect. So there's a very fun example here that you can take a look at in the EX27 project in my Java 8 folder in my live lessons GitHub repository. And this performs web services using the word in quotes because they're not really web services, although I have an implementation that uses web services that we'll talk about at some point. And they perform the web service operations from a client perspective using timeouts to do stuff if the web service takes too long to respond, or web services. And here's what the program does. It starts out by asynchronously finding the best price for a flight. So it says, find the best price between London and New York City. And that runs off in the background. Pretend, for sake of argument, it's calling a web service to find that. And that will use the default executor, the common fork join pool. We then asynchronously query to find the exchange rate between British pounds and US dollars, which normally back in the day would have been sort of 2 to 1. There was like 2 British pounds per US dollar. Lately, because of the fiasco that is the British government at the moment, it's about 1 to 1. So rather embarrassing, but I guess they have a prime minister at last, so that's good. We'll see whether he lasts more than the previous one. By the way, the previous prime minister, the one who resigned, Liz, I think Liz Truss maybe, she's one of the very few prime ministers in recent history to serve under 2 monarchs. Even though one of them was only for like a couple days, but that's another story. So, and I can't even begin to imagine when the last time that happened. So what we do here, when we do the exchange rate query, we're going to have this complete on timeout call, which is going to say, if we don't find out what the exchange rate is within 2 seconds, we're going to take the default rate. So that's an example of giving a default if a timeout occurs. And no matter what happens, we're going to use the convert method, which we'll talk about in a second, to take the results that come back from finding the best price and take the result that comes back from finding the exchange rate, and it'll do a conversion by multiplying the price by the exchange rate. So that's the then combined. Remember, that's that completion stage method that triggers an action, in this case, the convert method, when 2 previous stages complete. And by the way, you might wonder why we didn't use then combine, then apply async, but instead we used then combine with supply sync. And that was because we wanted to be able to kind of chain together complete on timeout here. So the next thing we do, just to kind of flesh the example out a bit more, we use or timeout. And what or timeout says is, if the whole computation up here takes more than 3 seconds, throw the timeout exception. This timeout said if it takes more than 2 seconds to get the exchange rate, then use the default exchange rate. This says if all of that took more than 3 seconds, throw the timeout exception, because we're just not going to wait around that long. And we could quibble about whether it should be 3 seconds or 5 seconds or 2 seconds or whatever, but I just set that to give an example. And then we use the when complete exception handling completion stage method to print out what happened. So this call, if you remember, will always be called back no matter what happens, whether an exception is thrown or not. If an exception is not thrown, we print out the final price, which will be the amount in converted price. Otherwise, we print out what went wrong. We'll print out the reason why the exception occurred. So that's a fun little example that illustrates using the timeout mechanisms in Java 9 and beyond. Just for kicks, we're going to show how to use the complete async method. So this is called test fraction multiplication complete async, which is in my EX8 project in the Java 8 folder in the live lessons repository. We start out by making a string builder to hold the intermediate results. We make a couple of big fractions. We create an empty completable future. And then we use the then run computation. And this registers an action that will append a string when we run the computation. So you can see it's going to go ahead and have a string that says what we're doing. We then go ahead and use complete async on this completable future, which will trigger this then run call and then run the supplier lambda in the common fork join pool. And so what we're going to do is we're going to multiply these 2 big fractions together in the common fork join pool and return the result. Kind of a weird thing. Honestly, I've looked long and hard and really was not able to find any good examples of using complete async for anything, but here's an example of it being used. And then that sets the wheels in motion. Things run in parallel, and then finally we join the results and print them as a mixed string. All right, so that's that example. I should mention one other little thing real quickly. With Java 12, they added an async version of the exception handling completion stage method, which I also don't really have a good use case for, but I think it mostly was there to have parallel structure with the other async versions of those exception handling completion stage methods. And I suppose if you had a long running exception handler, that might be useful.